which I spoke. Now you are able to hear me, guys? Yeah, from last 5 minutes I was blabbering something. Okay, anyhow, what I was saying is, let us start talking about remaining part of light chapter. I have already covered reflection part. Today my plan is to cover refraction, and we are going to learn about lenses and lens formula in today's class. So be attentive, be participative. Whatever I ask, try to answer that. What you know, you can recall it. What you don't know, you can learn it. And today my aim is to solve more numericals than talking about more theory. But definitely before going to numericals, I will take some theory and then I will start talking about numericals. Okay, that is the plan. So let us start talking about this chapter from the scratch, and let me ask you, what is the meaning of refraction? Yes, Mr. Srihari, what is refraction? Bending of light. Bending of light. Why light bends? Sukesh. Change in medium. Why light bends? Because of changing in medium. Change in optical density. Why light is bending? Because of changing optical density. That is the main point. You should say that speed of light in different mediums are different, and that's why when it travels from one medium to another medium which has different optical densities, it tends to bend. If it is moving from a denser medium to a rarer medium, it will bend away from the normal, and if it is traveling from a rarer medium to a denser medium, it will bend towards the normal. This is how light travels. Either it will bend away from the normal or it will bend towards the normal. That depends upon from which medium to which medium the light is going. So if I ask a question to you, the question is from Bhupesh. The question is, under which two conditions, even if the light is traveling from one medium to another medium, it does not undergo refraction? How we call it? There is a technical word for it. Not mutually perpendicular. Second case. Ashwat. What is it called as? It has a name. Anybody who knows?
Incidence, sir.
Tell me again. Normal incidence. Very good. Normal incidence is the word. Normal incidence means angle of incidence is 0 degree. So when it is a normal incidence, second, optical densities of both the mediums are same. If optical density of the first medium and second medium are same, and it is a normal incidence, in both the scenarios, you will see light has gone from one medium to another medium without any bending. Are you getting? That is the condition of no bending. Okay. Otherwise, if the light is going from one particular medium to another medium, for example, if I am drawing light going from, I am drawing a glass here, and I am assuming from a glass slab, light is entering from a rarer medium to a denser medium. How will it bend? Towards normal. Step number 1, whenever you have a refraction diagram, should be to draw the normal. So if I draw a normal here, I will be getting angle of incidence. Once you get the angle of incidence, then this was the original path, isn't it? But it will not go in this path, rather it will bend towards the normal. So it will go like this, isn't it? Now once it comes to this point, here I will draw the normal. Now it should go ideally straight, but it won't go ideally straight, rather it will take a bend away from the normal. So in the case when the light ray was moving from denser medium to a rarer medium, it bends towards the normal, and if it is going from a rarer medium to a denser medium, it goes away from the normal. Now what should, what, tell me again? Yeah. Ulta I wrote. Rarer to denser here, and here dense to rarer. Yes. Now what you should remember is, this ray which is called as emergent ray and this ray which is called as incident ray will always be parallel. Why it will be parallel? Because whenever the light ray is passing through a rectangular glass slab, and if the first medium and the last medium are same, that is first and 3 are same, isn't it? Here air, Here we have glass, here we have once again air. So if the first medium and the last medium are same, the angle of incidence will always become equal to angle of emergence, and so the line becomes parallel. Even if we have multiple mediums like this, multiple mediums, medium 1, medium 2, medium 3, medium 4, again medium 1, then now different ways refraction can happen, like this, like this, like this, but final ray and the first ray will be parallel to each other if the first medium and the last medium are same. You should remember this, that if the mediums are same, then the light will travel straightly. Sit here. No. Sit there. Yes. Is it clear to you? I hope it is clear to you. So remember this, first medium and last medium, check them if they are same, but if they are different, it may not be there. It may even go and bend in some other direction. Only if the first medium and the last medium are same, then the incident angle of incidence and angle of emergence would always be same. Okay. This is a very basic thing of refraction. Next comes refractive index. Have I talked about these things earlier? Maybe if I have talked, even once again I will repeat it. So what is refractive index? Yes, refractive index is extent of bending, or it is a tool which is used to measure the optical density of the medium. See, optical density we said, but whether it is mass density, kg per meter cube, no. Optical density is the permission given by the medium for the light to go inside it, and that is measured by different parameters. One such parameter which measures the refractive index is called as, measures the optical density is called as refractive index. It is given by small n in NCERT book. If you go to higher class, they will use mu. Some books will also write mu, but NCERT writes n. Now, refractive index is basically of two types. One is called as absolute refractive index, another is called as relative refractive index. I think I have talked about this, once again I am repeating it. So always remember, absolute refractive index means refractive index of a medium with respect to air, always with respect to air, and or vacuum, whatever. Or relative refractive index is refractive index of two different mediums other than air. See, generally if you see air and vacuum have different refractive index, I agree, but minute difference is there. So we are using as mu of air as 1, but actually mu of vacuum is 1, to be very exact. So if suppose I am writing refractive index of water is how much? Anybody knows this? How much is the value? 1.4 by 3. 4 by 3 is 1.33. So 1.33 is the refractive index of water. With respect to whom? Only with respect to vacuum or air. Because this is not absolute, it's not a, we say it as absolute refractive index, but actually water's refractive index, if you compare with diamond, it will not be same. With glass, it will not be same. Only with respect to air, it is this 4 by 3. So how do you define absolute refractive index? It is defined as, I am writing mu, actually it should be written as n, because you are using it as n only. So the formula of refractive index, which is absolute refractive index, is C by V. That is speed of light in vacuum divided by speed of light in that medium. For example, if I am writing n of water, then it will be C by V in water. It means it gives you an idea how fast or how slow light moves in a particular medium with respect to air. For example, if I say refractive index of diamond is 2.42, it means that it will be equal to C divided by 2.42. Am I right? Isn't it? It says that I should say C divided by 2 V of W. It says that V of W will become equal to C divided by 2.42. It means the velocity of light in water, not water actually, diamond, is 2.42 times slower as compared to speed of light in vacuum. Isn't it? For example, here I have talked about water 4 by 3. So if I am writing n of W, as per the formula it will become C by V of W, right? If it is C by V of W, what does it mean? It means that V of W will become equal to C by NW. It is 1.33. It means light travels 1.33 times slower in water as compared to air or vacuum, whatever you want to say. So, refractive index, which is absolute, is actually speed of light in vacuum divided by speed of light in that particular medium. What happens, Santosh? Any problem? You can come in the front. I should not hear any voice. Next is relative refractive index. Relative refractive index is always the comparison with some other medium. Nikhil, I think you are unmuted. Please mute yourself. Yeah. So, relative refractive index. The same thing. Now, if suppose I want to compare water with glass, then what will be the refractive index of water with respect to glass? How will you find that? That will be equal to refractive index of glass. I am asking refractive index of water with respect to glass will become NW by NG. That will become equal to what? What is NW? NW is what here? NW is equal to C by VW. And what will be NG? C by VG. CC gets cancelled. So, I can write refractive index of water with respect to glass, which is equal to refractive index of water by refractive index of glass will become equal to velocity of light in glass by velocity of light in water. Do you understand this relation? One more thing I will tell you. You know that in sound in 9th you studied, V is equal to nu lambda. You remember this? Velocity is equal to frequency into wavelength. From here board questions are coming. So, I can write one more equal to, I can write V as nu lambda G by nu lambda water. Nu gets cancelled because nu is frequency. Frequency is source dependent, but wavelength, frequency is source independent, but wavelength is source dependent. It means that if I want to write a general formula of refractive index, I can write like this. Pay attention. I can write like N12 is equal to N of 1 by N of 2 is equal to V of 2 by V of 1 is equal to lambda of 2 by lambda of 1. Very important relationship. Many of you may know up to here, may not know this lambda 2 by lambda 1, but it is really important because how the question is coming, I will tell you. Question comes like, if light is moving from one medium to another medium, whether frequency changes? Answer is no. Velocity changes? Answer is yes. Wavelength changes? Answer is obviously yes. Wavelength, velocity are medium dependent and frequency is source dependent. Write it down somewhere if you do not know. That is velocity and wavelength. They are what dependent? Medium dependent. They are medium dependent. Whereas frequency is what dependent? Source dependent. So, frequency will not change of the light if it is moving, traveling in any medium. Water, if it is moving in glass, moving in diamond, moving in air, frequency will always be the same. If it is blue light, it will always remain blue only. Blue will not become green. Are you getting my point? Blue is the frequency, which is representing frequency, but wavelength will change because the medium is changing. Velocity obviously is changing if the medium is changing. So, keep this in your mind. This question has come in the board examination where they have asked the same question that I asked you, that if the light is traveling from one medium to another medium, which quantity does not change? The answer is frequency does not change. Velocity and wavelength do change. I hope it is clear to you. These things I have talked already in the previous some class, I remember. I am once again repeating it for you. So, relative refractive index is refractive index of one medium with respect to another medium. If I want to write in terms of velocity, it is V2 by V1. If I want to write in terms of lambda, it is lambda 2 by lambda 1. Clear? Can I proceed further? Then in this chapter comes lenses. Let us not, anybody saying something online? I hope nobody. Please pay attention. Lens. So what is a lens? Anybody who can define? Soumya, online. I'll come. Combination of mirrors. Very good. I'll come to you. Yes, Soumya, I asked you. If you are hearing me, unmute yourself. Soumya, SSM Nagar. If you are there in the class, unmute yourself. Otherwise, okay, I cannot wait further. Pratika. Pratika, if you are hearing me. Transparent medium? Two surfaces. Which surfaces? Any surface. So many people have, they are joining and they are going somewhere else. Pratika, you are able to hear me?
Yes.
Why are you not saying yes then? I have to wait for 2 minutes for your yes.
You want supporting me, sir.
Okay, now you just reply to me that what is a lens?
The lens has two-side reflecting surface.
Two-side reflecting surface. Gautam, what is a lens? Unmute yourself.
The lens is the spherical
Part of?
it's a glass.
Okay. Tarika, what is a lens? Unmute.
Yes, sir.
What is a lens, I asked Tarika?
Well, both the sides are spherical.
Both the sides are spherical. I'll come back to the right answer. Nikhila, what do you think? What is a lens? Unmute yourself, Nikhila.
Sir, two glass attached.
Two glass attached. What glass? Any glass. I have a glass like this. I have another glass like this. I attach both. Is it a lens, Nikhila?
Transparent. Yeah.
Transparent. Okay, they are transparent glass only. I am having one transparent glass, another transparent glass. I am attaching them and making like this. Does it become a lens? What happened here? We can talk all these things after the class gets over already. Sultan, you can speak something about lenses?
Sir,
Yes.
two spherical glasses, sir.
Two spherical glasses.
Transparent spherical glasses should be joined together.
Okay. Anybody else who has any other answer, or all of you are agreeing with what Sultan has said? Two spherical glasses joined together, transverse direction, he says. Anybody else? Yes. Anybody else who's having some other opinion?
Disperses light beam by refraction.
Disperses. You went to prisms. Okay. No, not like that. Anything else? Anybody wants to add in this? Actually, nobody is right. Yes, Ashwath.
Sir,
I'll come, Vibhusha, to you. Once again, Vibhusha, I will come to you. Yes, Ashwath. Yeah, tell me. Which surface? Any surface? Spherical or plane? Okay. Vibhusha, please.
sir, combination of more than one glass can be defined as lens.
Okay, combination of more than one glass. That glass, these are two glasses, right, Vibhusha? Glass 1, glass 2. I combined both. Is it a lens?
Sir, magnifying glasses with curved sides.
Only magnifying glasses can be lens, Kishore. If it is not magnifying, it is not lens.
Sir,
Please.
any transparent objects are bound together, which is of spherical shape.
That's what. Okay, now I'll tell the answer, please. Most of you are thinking that if there are two transparent surfaces and they are bound together and they are spherical in nature. Pranav Aditya, your name, right? Come, sit here first. Come here first. So those two surfaces must be spherical. That is the biggest mistake that you are doing. For any lens, we don't have requirement of both the side to be spherical. If one side is spherical and one side is plane, even this is a lens. This lens is called as plano-convex lens. Remember that. I think you told. So I think the book you told. Right, Ashwath? Yes. Definition of lens is two transparent mediums bound together in which one of them must be spherical, not both of them. One of them must be spherical. One can be plane, another can be spherical or plane. Are you getting my point? But this surface must be spherical. So if one side you have spherical surface, one side you have plane surface, this is also a lens. It is called as plano-concave lens. Are you getting a point? If both side you have convex lens surface, then it is called as double convex lens, equiconvex lens, or just convex lens. If both, biconvex also we can say. If both side you have concave surface, you can call them double concave lens, equiconcave lens, biconcave lens, or just concave lens, isn't it? Or like this, we have plano-concave and plano-convex. We can also have something like this. Are you knowing? It is also a lens, convexo-concave lens or concavo-convex lens. These things will come in detail in higher classes, because in your syllabus now you learn only about this double convex and double concave lens. So double concave and double convex lens definitely have been derived from two spherical glasses only. But don't think that lens should have both sides spherical. No, lens may have one side spherical, one side plane, both spherical, but both plane not allowed. Are you getting my point? Vibhusha, Nikhila, everybody clear in this? The definition of lens is there in NCERT book also. Bad thing is still you have not read NCERT book line by line. You are going to write board examination in another 40 days. Please go through these things, basic things. It may come for 1 mark and you may lose mark. Fine. So if I talk about any lens, like in your syllabus we have two kinds of lens. One is called as equiconvex or double convex or just convex. Another is called as concave lens. Now as you see, this convex lens would have been derived from two spheres. One sphere like this, another sphere like this. Same way this concave lens would have been derived from two spheres. One sphere like this, another sphere like this. And when you have sphere, you must have a center of the sphere, isn't it? Those centers of the sphere are called as center of curvature. I am writing it as C1, writing it as C2. NCERT book also writes 2F1 and 2F2, your wish. When you go to higher class, you will be taught that this must be C1, this must be C2. Reason is, first side, so it will become C1. Second side will become C2. That's the way you should write C1, C2. But I think NCERT book writes one left side F1 or right side F2. Okay, fine, no problem in that. In this case, once again, this is the first side, so it will become C1, and this second side will become C2. Center of curvature 1, center of curvature 2. When you join a line which is passing through both the center of curvature, this line is called as principal axis. Now, when I draw a line passing through the center of the lens and cutting the principal axis perpendicularly, this point is called as optical center, right? It's a very beautiful point. I will come to one question to you. Most of you I think will make mistake in that, but let me ask that little later. Optical center. Then when the rays are coming parallel to the principal axis, they tend to converge at one point. That point where they are converging, that point is called as focus. Yes.
What if the lens have different radii?
Then it will not have same C1, C2. Suppose one lens is having like this, another lens is having like this. It may have a different C, it may have a different C. Then what is the question, by the way?
Will the lens have same radii or different radii?
It depends on how you are manufacturing it. Lens need not to always have same radii both sides. If it is having same radii, it is called as equiconvex lens. But we can manufacture lens, one side having more radii, one side having less radii. It's our wish. If we manufacture, we can manufacture like that also. In that case, what will happen? Here the focus will be different, here the focus will have different. Focal length will be different, focal length will be different. Possible.
They converge at the same point in this case.
Depends upon this side. See, once again I'll tell you. To answer your question, let me go a little deep. You want to go home? Sanchita, right, your name? I don't want to see hear your voice once again. If I hear, I'll send you back home. Okay? See the lens. Lens is here. I am talking to Ashwath. Deep concept this is. I don't know how many of you have observed this. When a light comes here, how you draw generally? You draw like this, isn't it? This is how you draw. But is it true? Like what we are drawing is actually not true. You know why it is not true? Because light should not go straight from here. Light should bend here itself, isn't it? The moment light is coming from air and going to glass, it must bend. So, let me go back and once again redraw. The correct diagram should be like this. The light is coming, hitting here. The step 1 I told you when I was talking about that glass slab, you should draw the normal. How to draw the normal? What you will do, this part of the lens will have its own center, right, Ashwath? From that center, if I draw a line, this line will become the normal. Now what I do, I will bend. How it will bend? Towards or away? It will bend towards because it's going from which medium? Rarer medium to a denser medium. It will bend towards the normal. So instead of going like this straight, it will take a bend towards the normal. It will go like this. But will it come out? It will not come out directly. It has to bend. Why it has to bend? Because it is going from a denser medium to a rarer medium. Once again you should draw a normal. How will you draw a normal? Here you have C1. You will join this C1 with this point, you will get normal. So any point of the lens, if it is joined to the respective center of curvature, you get the normal. So any point, if I join like this, join like this, join like this, join like this, all these lines are normal lines. Remember that. Okay, coming back. So now the light ray, which was supposed to go straight, will not be able to go straight. It will take a bend. How? Away or towards? Away. So instead of going towards the normal like this, it will go away. So it will go like this and bend. Do you understand, Ashwath? This is the working of bending. So what we don't draw all these complexities. How we directly draw in our NCERT book also. We'll take an object, we'll take a line, and from center we'll bend and pass like this, F, isn't it? But what is happening inside? All these things are happening inside, which you are drawing like a straight line. Now, as your question says, if one side I have a different curvature and this side I have a different curvature, like this, same thing will happen. It will follow the rules. Line will come. For this curvature, will be a center. I will draw a normal. I will draw a bending. For this part, there will be a normal. I will draw a bending. It will bend like this. It may have its own focus, but focus of this side will be same. This side will be same. That will not change. What will happen in this case? If I keep the object 20 centimeter here, wherever is the focus, if I keep the object this side, will have the same focus that side also, isn't it? But not in this case. Here, if the focal length this side is 20 centimeter, here it may be 10 centimeter or 30 centimeter, because the curvature is not same. Are you getting my point? So coming back to what we were discussing. So we are discussing about lens different points. So I hope you understand what is the meaning of principal axis, what is the center of curvature, what is the focus, what is the focal length, what is the radius of curvature. So we know that what is? I'll talk about aperture. Let me come to that point. See here, before that, I'll come to aperture, man. So from the optical center, if you join the focus, what is it called as? Focal length. From the optical center, if you join the center of curvature, what is it called as? Radius of curvature. What is the relationship between F and R? R is equal to right? Wrong. It is not valid in the case of lenses. Remember this. One question has come in the board examination 10th. If a mirror and a lens is immersed in water, a mirror and a lens, if they are immersed in water, what will happen to its focal length? Will it change or not change? For mirror it will not change, but for lens it will change, because remember this, write down somewhere if you are writing. Focal length of lenses are dependent on R and refractive index. In higher class you will learn the formula. The formula is 1 by f is equal to mu minus 1 or n minus 1 into 1 by r1 minus 1 by r2. This formula relates focal length, refractive index and radius of curvature. It means that if a lens is kept inside the water, its focal length will be different than what it is there in air. But if a concave mirror or a convex mirror is kept inside the water, its focal length will not change. 10 centimeter inside the water, 10 centimeter. But lens, focal length 10 centimeter outside, put inside the water, it will be different. It won't be 10 centimeter. Actually, it will decrease. Why and all, let us not go in that much deep, not required for 10th standard. But this question has come that whether f is equal to r by 2 in lenses, no. F is not equal to r by t, f is equal to this. This is the formula of f and r. Only in mirrors, r is equal to 2f. Remember this, r is equal to 2f is only for mirrors, not at all for lenses. Is it clear? Very basic thing I am talking. Now my question to all of you is that you would have heard that if a ray is passing parallel to principal axis, it converges and goes through focus, or it diverges and seems to pass through focus. If any ray is passing through focus after refraction, it becomes parallel to principal axis. Heard these things? If any ray is passing through optical center, it goes undeviated. Have you heard this? Why? The rule says that.
Incidence is zero, sir.
What? Tell me again.
The angle of incidence is zero.
No, Raghav, that is only for mirrors. I'll tell you. No, that is only valid for mirrors. I understand what you are saying. I have asked the same question.
Incident ray is perpendicular to.
Let me come to you, Raghav. I understand what you are thinking. You are relating the same concept of center of curvature of mirrors as center of curvature with lenses. It's not true. I'll tell you why. Here what I said you, whenever a ray is coming, suppose a ray is coming like this, we make the ray to reflect and pass through focus in this case. But what is the first thing? You should draw a normal, and normal passes through what? Center of curvature. So if a ray is coming through center of curvature, it is coming on the normal itself, angle of incidence is 0, so angle of r will be also 0. That's why it bounces back. That's why in mirrors we say that if a ray is passing through center of curvature, it will retrace its path, right? But in the case of lens, now coming back, pay attention Raghav and here Santosh, those who have told that perpendicular thing. Let this be f, let this be 2f or c. Here also we will have f and we will have a 2f, right? Right. Now I am having an object here. So you think that the ray is coming. At this point, what we will do? We will draw a normal. Normal should pass through where? F, 2f only, no? 2f, isn't it? So what will happen if the ray is passing through optical center? This is not the normal point itself. Then why is my ray going straight? Optical center is not center of curvature, right? So you cannot say that if the ray is going through optical center, it is the normal. I did not tell you that from optical center we are drawing the normal. Normal is only from center of curvature. Then why when a ray is passing through center of like optical center like this, it will go undeviated straight? Why is it so? Can you tell me? Anybody can throw some light on this? Anybody online? Any idea? Be a little louder, man. Pratish.
Sir, the optical center and the center of curvature are the same line, sir.
Are the same lines. Why you are saying like that? Oh, you are saying the optical center, they are, it is in the same line. But I am not talking about the ray coming in this direction, right? I am telling ray is coming in some angle. Then how we can call this as normal incidence? Pratish. Can you call this as normal incidence? I don't think. There is no relation of normal incidence here. Normal incidence is not happening itself. I am itself telling you. Then what is happening that the light is going straight? Anybody wants to try online, or shall I give the answer to you? Ashwat, something if you know, you can try. Okay. It bends. But we are drawing straight. Why? We can draw straight here also. We can draw straight here also. Why only here you want to draw straight? Special care. Don't waste my time.
So since both having the combination of two mirrors.
Okay. Mirror is. Why are you using the word mirror? I don't understand. Do you think it is mirror?
No, sir, the lens is made by the processor.
Mirror.
No, combination of glasses.
Glasses. So,
So it acts like that.
don't say something for the sake of saying. It's not exam that you will get some mark. I'm asking to check how much you know. Anybody else who can comment on this?
Center of the lens, sir.
Nothing to do with that.
It's a density change.
No. Now pay attention. I'll come to this. Suppose you have a rectangular glass slab. Okay. Light ray goes, it bends, again it bends and goes here, right? And I said you that how much is this displacement d? If you don't know, I'll tell you now. It totally depends upon what is the thickness of this. Extent of lateral displacement is a function of thickness of the glass slab. The less the thickness, the less lateral displacement. You know one thing, in your school laboratory, all of you would have done this experiment, right? Having a white paper, keeping a rectangular glass slab. Shall I off the AC? Then say off the AC. Rectangular glass slab, putting two pins there, seeing from here, putting two pins here. Have you done this experiment in the school?
Yes, sir. Yes, sir.
Okay. You would have seen that the light ray is bending really. You would have felt it. Okay. Now if you see that side, one glass is there in this room itself. Glass is there? Somebody sitting that side? Revan sir is sitting there. Do you think that his position is changed from here?
No, sir.
Glass slab is there between you and him. But whatever is kept there, can you feel that there is a change in position? You will never feel. Thickness is very less. Because thickness is very, very less. So always remember that if thickness is less, this displacement will become very, very small. It will not be visible to you itself. It will not be felt by you itself. Now coming back to lens. If I am having a convex lens or a concave lens, its central part behaves almost like what? A rectangular glass slab.
Thickness is more in lens.
Yeah. More in lens or less in lens. What we are dealing in our school, 9th, 10th, 11th, 12th is only thin lenses. We never talk about thick lenses. So lens is very thin and central part of the lens is what? Behaving like a rectangular glass slab. If thickness becomes very less, then the bending will become very less. And so your ray will seem to pass almost straight. Are you getting what is the reason for that? But no other part the same phenomena takes place. So central part of the lens behaves like a rectangular glass slab, and since we are dealing with thin lenses, the thickness of the lens is very low, and so the bending is very low, and that's why the light ray goes straight without any bending. Whatever I am talking to you is something deep concepts. If the question paper is very tough, only then it can come in the examination, or else they will not be asking these questions in the examination. But what if the question paper is tough? They may go this level also, where they may ask you, why is ray passing through optical center not having any bending? What will be the answer you will write? Because central part of the thin lens acts like a rectangular glass slab, and the extent of bending totally depends upon the thickness of the glass slab. Here, since thickness is very low, the bending is very low. Is it clear to you? Okay. Coming back to, you asked something, aperture you asked. So, aperture of lens is always, it means how much is the, see, this lens. Yeah, I can. You should have asked me. Can I? After some time. Time is not much remaining, don't worry. Yes. What is the difference between these two lenses? Okay, so what will happen to the light ray falling on it? If I am having two lenses, one is having like this, one is having less thickness like this, what is the difference between these two lenses? Velocity by earth going, bending just go. Which will have more focal length, this or this? One or two, which will have more focal length? One will have more focal length. Two, obviously, because two is derived from a bigger sphere. Can you feel? This will have a smaller sphere. Can you feel it? If I make it further bulged, it will have further smaller sphere, isn't it? Are you feeling that? So, as we make the lenses bulged, then its capability to converge light changes. It reduces actually. So, the more less bulging is there, the more bigger the sphere will be, and the light will focus little later. Are you getting my point? This is only known as aperture. Aperture means how much you are making it thin such that its focal length is increasing. Are you getting my point? So, if I compare this lens and this lens, which is having more aperture, this aperture. In the case of mirrors, if I am having like this and like this, which will have more aperture, this one. Are you getting my point? Don't think this will have more aperture, this will have more aperture. Got it? Coming to the image formations. So, image formation of lens, I hope you know. I will ask one by one to all of you and I will draw it. So, lens, convex lens image formations are very similar to concave mirror, and concave lens image formation are very similar to convex mirror. If you know that mirrors, you know the lens also, that is the thing. So, if I keep the object at various positions, let me ask and let me check how much you remember the image formation, right. So, I will start with Ashwath. Yes, if I am first I am talking about convex lenses, okay. This is a what lens? Convex lens. So, in convex lens, if the object, let this be optical center, let this be focus, let this be 2f, once again this head be f, this will be 2f. So, the question is for this color is too light. Okay. So, first position is object at infinite, second position is object beyond 2f, third is object at 2f, object between f and 2f, object at f, object between f and o, right. Ashwath, if the object is at infinite, where will the image be? You are Ashwath, I will come to you, man. At f2, its characteristics? At focus, over, done. Yes, what is your name? Sitting. Sudarshan, oh, you are Sudarshan. Sudarshan, tell me, if the object is beyond 2f, where will the image form? Between f and 2f. Very good. Its size? Good. At 2f, yes, you. I don't know the name much. Paul, some Aditya. No, Aditya is this boy. What is your name? Sai Prasad, yes, tell me Sai Prasad. Object at 2f, image will form at f. Bhupesh. f2, 2f2, 2f, and its size will be same as the object, real and inverted. Okay. So Srihari, what is the difference between a real image and virtual image? So question came in the exam. Write difference between real image and virtual image. What will be your answer? Yes. Oh, real means as how the object is, and virtual means different from the object. Very good. Yes.
Falling on surface.
Okay. Falling. Virtual will fall on air. Then falling on surface is real. Falling on moon is virtual. Where then? What is virtual? Okay. Where it will form then? Somewhere. Okay. Anybody who can define in online people the difference between real and virtual image?
The real image is actual intersection of light rays. Virtual is
Virtual is
not the actual intersection.
we make it to intersect, isn't it? Good. So real images are those images which are formed by the actual intersection of rays. This, and this, 1, 2 and 3, they are formed by the actual intersection of rays, isn't it? Now Srihari, if the object is between f and 2f, where will the image form? Object is between f and 2f, fourth. Where will the image form? Beyond 2f2, where size will be, I have drawn for you. See and say at least. Enlarged, real or virtual? Very good. See here, it is inverted. How can it be virtual? Virtual inverted, you are reading. Real only, obviously. It will be real, inverted, enlarged, beyond 2f. Sukesh, at f, where will the image form? At size, highly enlarged, nature, and real, obviously. Yes. Pranav Aditya, sixth position, object between f and o. Behind the mirror. Behind the object. On the same side of the object, and it will be virtual, erect, size will be enlarged. Isn't it? Behind the object, more proper thing is you can write on the same side of the object. Behind the object, obviously it is behind the object only, but it is on the same side of the object. Okay. These are the image formations. You must know the image formations by ray diagram also. I'm not going to go into that now. We don't have much time for doing that. But I hope all of you are aware about how these diagrams are formed, right? By using the image formation rules. If the ray is passing parallel to principal axis, it will refract and pass through focus. If the ray is passing through focus, it will become parallel to principal axis. If the ray is passing through optical center, it will go undeviated. By using these three rules only, all the image formations are being done. Okay. Now, if I ask about a concave lens, optical center, f, 2f, once again f, once again 2f. So, yes, Mr. Kanishk, if you are there in the class and not gone to play football, what if the object is kept beyond 2f? Yes, object is at infinite. Where will the image form? At its nature? Okay, whether it is real or virtual? Good. Next question is to Shrina. Shrina, if the object is beyond 2f, where will the image form? That much time is not there.
Sir,
Not at focus. No. Kishore?
Sir, beyond 2F1, sir.
Very good. How can you, yaar? Always remember that.
I'm asking the question, sir.
Yeah, beyond 2F only.
Sir, the object will be found at F1, sir, and it will be highly diminished point sized
At F we are saying.
at F1, sir.
Here.
Yes, sir.
Okay. First of all, will the image form here? Never. It will form on this side for the first case. And for all the other case, it will not form at focus. It will form between focus and what? Optical center. So it will be something like this, like this, like this. It means it is always going to be virtual, erect, diminished between O and F. Wherever the object may be, the image will always be between O and F, virtual, erect, diminished. So convex lens is capable of creating real image, virtual image, real enlarged, real diminished, virtual enlarged. This lens is capable of creating only virtual image that is diminished. No other possibility is there. It cannot create virtual enlarged, it can never create real images. Right? Now, the lens formula is 1 by f is equal to 1 by v minus 1 by u. And what is the magnification formula? M is equal to plus v by u. Isn't it? Obviously, it is equal to hi by ho. Meaning of magnification itself is hi by ho only. Magnification is the ratio of height of image to height of the object. So, it obviously hi by ho only. Okay. Now, if I ask you that magnification is plus 2.5, what is the lens? Magnification plus 2.5. Fast, think and tell. Convex lens, isn't it? What is the position of object? Between F and 2F. Between F and O. Because plus 2.5 means virtual, erect, enlarged. Virtual, erect, enlarged, only one case possible. Case number 6 in convex lens. So it is a convex lens. Object is between O and F. Image is on the same side. Virtual, erect, enlarged. If I ask you, magnification is minus 1. What is the lens? Concave lens. Concave can never have minus. Convex lens only, yes. Where is the object position? At 2F, obviously. Because it is real, inverted, same size. Real, inverted, same size is possible only if the object is at 2F. Image will also form at 2F. Yes. Next question is for Ashmita. M is equal to minus 0.5.
M indicates real and inverted image. As it is below 1.5, it is
Below 1.5.
diminished 1.
Okay, below 1, yeah. Diminished, correct only.
Below 1, diminished. Real, inverted and diminished.
Very good. Which lens then?
Convex lens.
Very good. Which is the object position?
Object position will be beyond 2F.
Beyond 2F, very good. And the image will be? At which?
Image will be between F and 2F.
Very good. Between F and 2F. Next question is for Vijay. M is equal to minus 98,674. Vijay, minus 98,674. Tell me what is the lens and what is the object and the image positions, please.
Concave lens.
Okay. Concave lens, very good. Concave lens can produce real image, Mr. Vijay. Minus means real, right?
Sorry, convex lens.
Convex lens, then object position. object position. Any volunteer?
Between F1 and O.
Between F1 and O, then it will become virtual, man. Think and speak. If it becomes virtual, then how it is negative?
At F1.
At?
F1.
Why at F1?
Because it can only produce enlarged image.
Highly enlarged. Enlarged, can
Highly
you,
enlarged.
highly enlarged because it is 98,000. It is highly enlarged image. Highly enlarged image means the object must be at focus, isn't it? So answer is at focus. Is it clear? Last question for Raksha. M is equal to negative 0.000004. Comment on the object position, image position and lens.
It's a real and inverted image,
Very good.
highly diminished,
Yes.
and it forms on convex lens.
Yes.
Uh, the object position is at infinity, image position is at F.
Good, correct. Okay, F2 or whatever F. So fine, good, Raksha, good. So I hope you have understood whatever I have told till now. Today we could not do numericals based upon it. I will take another class where we will take numericals based upon whatever we have learned today. What remains is numericals based upon lens formula and power of lens. We will discuss in the next class. Okay? Okay, then take care. Bye-bye. We will meet again in the next class. You can drop off.
Thank you.